We will now discuss the TNB frame. So here we're going to let R of t be the parameterization of a curve. And at each time t, there are going to be three vectors that form a basis for a coordinate system. So at every point, we'll call that point, say, R of t. There are going to be three vectors. The first one is going to be the tangent vector. The second one will be perpendicular. That's going to be called the normal vector. And then the third one will be perpendicular to both. That's going to be called the binormal vector. So you can imagine that at every point I can draw a tangent vector, a normal vector, and a binormal vector that are going to define my coordinate system. And this coordinate system that changes as you move along the curve is going to be called the TNB frame. So we're going to start with the definition that we already know. The unit tangent vector at a point R of t is going to be the derivative of R of t divided by the length of the derivative. And then the normal vector is in fact going to be the derivative of the tangent vector divided by the magnitude of the derivative of the tangent vector, so that it's also a unit vector. And so I claim that the tangent vector and then the normal vector, which is the derivative of the tangent vector, that those two vectors are perpendicular. So how do I know that? Well, there's a clever way to prove this. The way that you do it is you take the derivative of t dot t. Now, the derivative of t dot t is the derivative of the length of t squared. And the derivative of the length of t squared is in fact 0. Because we know that the length of the unit tangent vector is 1 always, and so the derivative of 1 should be 0. But then we can use the product rule to compute the derivative of t dot t. So it's the derivative of the first t dotted with the second t left alone plus the first t left alone times, or dotted with, the derivative of the second t. So in fact, it's 2 times t dot t prime, because both of those expressions are the same. Well, t is the unit tangent vector, and n, the unit normal vector, is in the direction of t prime. So that means that t dot n must be 0. And so the unit tangent vector and the unit normal vector are in fact perpendicular. Okay, now that we have two vectors that are perpendicular, we want to find a third one. The most natural thing to do to find the third vector that is perpendicular to the first two is to take the cross product. So the unit binormal vector is actually going to be the cross product of t with n. And because t and n are both unit vectors, that will guarantee that b will also be a unit vector. So this vector, it does point in a direction that's perpendicular to t and n. So we're going to find the TNB frame for the curve cosine t, sine t, t. So that's that helix that we've looked at before. Okay, so first we need to find t. So that's going to be r prime of t, which is negative sine t, cosine t, 1. And then we need to find the length of r of t. So the length of r prime of t is in fact the square root of sine squared t plus cosine squared t plus 1. And so the length is the square root of 2. So that says that our unit tangent vector in this case is going to be 1 over the square root of 2 times negative sine t cosine t 1. And I'm going to leave the 1 over square root of 2 on the outside. It makes things a little bit easier. Okay, so that is our first vector in the TNB frame. Our next vector is going to be n. We know that that's going to be t prime of t, which is 1 over square root of 2 times negative cosine t, negative sine t, and 0, taking the derivative. And then we need to divide that by the length. So here I'm going to find the length of t prime. I can leave the constant 1 over square root of 2 out front. And then that multiplies by the square root of cosine squared t plus sine squared t plus 0. And so that length is 1 over square root of 2. So I'm going to divide t prime of t by square root of 2. That's going to tell me 1 over square root of 2. That's going to tell me that n of t, the unit normal vector, is actually negative cosine t, negative sine t, and 0. So that's my second vector in the TNB frame. And now, to find the binormal vector, I need to take the cross product. Okay, so I'm going to do t cross n. So this is going to be the cross product of, we're going to do negative sine t, cosine t, and 1. And in fact, I'm going to take the 1 over square root of 2 and I'm going to leave it on the outside there. And then n is negative cosine t, negative sine t, and 0. And so when I take that cross product, and I'm not going to go through every detail, but I'm going to get 1 over square root of 2 times, the first component is going to be sine t. The second one is going to be negative cosine t. And the third component is going to be 1. And so that is my binormal vector. So b of t in this case is going to be 1 over square root of 2 times sine t, negative cosine t, and 1. And so those are the formulas for t, n, and b. And then along that helix, They are going to define a coordinate system, which has like a tangent vector, okay, a normal vector, and then that normal vector is going to point inward, and then a binormal vector. So let's see what this looks like. We can at least see the tangent vector and the normal vector if we look at this in CalcPlot 3D. So here is the helix, cosine t, sine t, and t. Okay, and if you look, there's the red helix. In green is the normal vector. In black is the tangent vector. In blue is just the vector r of t. But we can see how the normal and tangent vectors change as you go around the helix. This one does not plot the binormal vector, but you can get an idea that it would be perpendicular to those two vectors.